Hello student, in my previous video I had completed the lectures on the derivative of composite function. Okay, now we will start the new function, derivative of new function, which is the inverse function, derivative of an inverse function. Now in this video I will explain the important theorem and solve examples and all the problems from the exercise 3.2 in a very simple language. नमस्ते विद्यार्थी मित्रों, यापूर्वीच्या व्हिडिओमध्ये मी एक्सरसाइज 3.1 हा कंपोजिट फंक्शन साठी घेतलेला आहे. आता या व्हिडिओमध्ये डेरिव्हेटिव्ह ऑफ इनव्हर्स फंक्शन बघणार आहोत. त्यामधले इम्पॉर्टंट तो थेरम, त्याचा स्टेटमेंट तुम्हाला एक्सप्लेन करणार आहे आणि त्याचबरोबर सॉल्व्ड एक्झाम्पल्स अँड ऑल एक्झाम्पल्स फ्रॉम दी एक्सरसाइज 3.2 I will explain. Now let us start. Now the derivative of an inverse function. Let y is equals to f of b, a real valued function defined on an appropriate domain. Okay. The inverse of this function exists if and only if the function is 1, 1 and onto. For example, let f is a function defined from R to R, set of real number to the set of real number, be such that f of x is equals to x plus 10. Then the inverse of f is f inverse R to R is such that f inverse of y is equals to y minus 10. Then see this, how this y minus 10. Now we have f of x is equals to y is equals to x plus 10, and therefore what about here? X is equals to y is equals to x plus 10, and therefore x is equals to y minus 10. Now here see this, f of x is equals to y. जर समजा f of x is equals to y असेल, then what about the f inverse of y? Then x is equals to f inverse of y. And what is the value of x then? X is a y minus 10. And hence, first, if the f is a function defined from R to R, f of x is equals to x plus 10, then its inverse is defined from R to R such that f inverse of y is equals to y minus 10. F inverse of y is equals to y. F of x is x plus 10. What about its inverse? F inverse of y is a y minus 10. You can find out the value of x in terms of y. Because f of x is equals to y. Here f of x is equals to y, but f of x is x plus 10. Then find the x. Okay, that is equals to y minus 10. Now see this is the important theorem. Okay, it's a statement. If y is equals to f of x is a differentiable function of x such that the inverse function x is equals to f inverse of y exists, then x is a differentiable function of y, and hence dx upon dy is equals to 1 upon dy by dx, where dy by dx is not equals to 0. Okay, again I will repeat this statement. If y is equals to f of x is a differentiable function of x such that inverse function x is equals to f inverse of y exists, then x is a differentiable function of y. Means x is a function and then y is a variable. It can be written as dx upon dy is equals to 1 upon dy by dx, where dy by dx is not equals to 0. Okay, according to this statement, this rule, we will find out the derivative of the inverse function. Okay. Now the solved example. Okay. The first example is find rate of change of demand x of commodity with respect to its price y. If x is demand and price is y. If y is equals to 20 plus 15x plus x square. See this here once again. Find the rate of change of demand this is the x, okay, of a commodity with respect to its price. Means what? You want to find out dx upon dy. But we have given y is a function of x here. Y is equals to 20 plus 15x plus x square. And hence, let y is equals to 20 plus 15x plus x square, differentiating both the sides with respect to x. Okay, first. Therefore, dy by dx, derivative of 20 is 0. Derivative of 15x, derivative of x is 1. Therefore, it is a 15. Derivative of x square is a 2x. Okay. And hence, by the derivative of the inverse function. What is that? Dx upon dy is equals to 1 upon dy by dx, where dy by dx is not equals to 0. Substitute the value of this dy by dx, which is the 15 plus 2x, and hence rate of change of demand with respect to its price dx upon dy is equals to 1 upon the value of dy by dx, which is the 15 plus 2x, and hence this is the answer. Okay. म्हणजे प्रत्येकदा काय करणार की y आलेला असेल तुम्ही डिफरन्शिएट फर्स्ट ऑफ ऑल विथ रिस्पेक्ट टू x. Then we want to find out the rate of change of demand, okay, with respect to its commodity price, means for dx upon dy. Then dx upon dy is equals to 1 upon dy by dx. Now the next example. Find the rate of change of demand x of commodity with respect to its price if y is equals to 5 plus x square into e raised to minus x plus 2x. Okay. Again y is equals to. Differentiate this first of all with respect to x. Derivative of 5 is 0. Derivative of x square and e raised to minus x. Here we will apply the product rule. Okay. Now keep this first function x square as it is. Derivative of e raised to minus x is a minus e raised to minus x. Next, keep this e raised to minus x as it is. Derivative of x square is a 2x, and hence is a 2x into e raised to minus x, and the derivative of last 2x, and that is equals to 2, and hence minus e raised to minus x into x square. This is the first one. Next is a 2x into e raised to minus x, and last is plus 2. Okay. And in this way, by the derivative of the inverse function dx upon dy is equals to 1 upon dy by dx, where dy by dx is not equals to 0, and hence rate of change of demand with respect to its price dx upon dy is equals to 1 upon the value of dy by dx, which is the minus x square into e raised to minus x plus 2x into e raised to minus x and plus 2, and this is the answer. Now the next question number 3. Find rate of change of demand x of the commodity with respect to its price y. Y is equals to 3x plus 7 upon 2x square plus 5. Okay. Now we will find out the derivative of this y with respect to x using the quotient rule. And what is the quotient rule? Y is equals to u upon v, and hence it's a dy by dx is equals to v into du by dx minus u into dv upon dx, and this divided by v square. Okay. Therefore, differentiating both the sides with respect to x, then you will get dy by dx is equals to first v 2x square plus 5, derivative of 3x plus 7, derivative of 7 is 0 and 3x is 3, minus 3x plus 7 into derivative of 2x square plus 5. Derivative of 2x square is a 4x. Derivative of 5 is a 0. Next, normal multiplication. Dy by dx is equals to 3 into 2x square. You will get 6x square. 3 into 5, 15 minus 4x into 3x, 12x square. 4x into 7, that is a 28x. Open the bracket. Then you will get 6x square plus 15 minus 12x square minus 28x. Okay. And then simplify. 6x square minus 12x. Then you will get minus 6x square. Next, minus 28x. Okay. It's as it is, and plus 15 upon 2x square plus 5 bracket square. Okay. And therefore, the dy by dx is equals to minus 6x square minus 28x plus 15 upon 2x square plus 5 bracket square. Therefore, again, by the derivative of the inverse function dx upon dy is equals to 1 upon dy by dx, where dy by dx is not equals to 0, and hence the rate of change of demand with respect to, okay, it's a price. So rate of change of demand with respect to its a price is dx upon dy is equals to 2x square plus 5 bracket square. Okay, if we substitute the value, it will become multiplied and reciprocal 2x square plus 5 bracket square upon minus 6x square minus 28x plus 15. Okay, these are all the solved examples. Now we will start the exercise 3.2. Now the question number 1, find the rate of change of demand x of commodity with respect to its a price y. Okay, now here y is equals to 12 plus 10x plus 25x square. Now differentiate this with respect to x. Okay, differentiate with respect to x, and therefore dy upon dx is equals to derivative of 12, which is the constant, its a derivative is 0. Derivative of 10x is a 10, and the derivative of 25x square is a 25 into derivative of x square is a 2x. Okay, and hence the dy by dx is equals to 10 plus 50x. Okay, now again by the derivative of the inverse function, okay, dx upon dy is equals to 1 upon dy by dx, where dy by dx is not equals to 0. Now substitute the value of dy by dx, which is the 10 plus 50x, and hence here is a dx upon dy is equals to 1 upon 10 plus 50x. Okay, dx upon dy is equals to 1 upon 10 plus 50x, and therefore the rate of change of demand x of a commodity with respect to its price, that is the dx upon this dy is equals to 1 upon 10 plus 50x. Okay, and this is the answer. You can see this again. Now we'll take the next problem. Again similar problem is here. Y is equals to 18x plus log of x minus 4. Now differentiate this. Differentiate with respect to x, and therefore dx, sorry, dy by dx, dy upon dx is equals to derivative of 18x is 18, derivative of log of x minus 4 is a 1 upon x minus 4. Okay, now we'll simplify this. 18 into x minus 4, that is a 18 in bracket x minus 4 plus 1 upon x minus 4, again dy upon dx is equals to simplification 18x minus 72 plus 1 upon x minus 4, and that is equals to, okay, here is a 18x minus 70, sorry, 18x minus 71 upon x minus 4. Again, by the definition of the inverse function, by derivative of inverse function, okay, therefore dx upon dy is equals to 1 upon dy by dx, where this dy by dx is not equals to 0, and hence therefore dx upon dy is equals to 1 upon dy by dx, means what? 1 upon 18x minus 71 upon x minus 4, x minus 4, and that's equals to x minus 4 upon 18x minus 71. Okay, and hence therefore the rate of change of demand x of commodity with respect to its price is, that is a dx upon dy is equals to x minus 4 upon 18x minus 71. Okay, and this is the answer. You can see this. Now the next problem number 3 is, okay, y is equals to 25x log of, in bracket, 1 plus x square. Okay, now differentiate this, with respect to x. Therefore dy by dx is equals to dy upon dx is equals to derivative of the 25x is a 25 plus derivative of log of 1 plus x square is 1 upon, that is 1 upon 1 plus x square into derivative of 1 plus x square. Derivative of 1 is 0 and derivative of x square is a 2x. Okay, therefore here 25 plus 2x upon 1 plus x square. Next simplification, 25 in bracket 1 plus x square plus 2x, and this whole divided by 1 plus x square, and that's equals to here 25 plus 25 x square plus 2x upon 1 plus x square. This is the dy upon dx. Now by the derivative of inverse function, therefore by derivative of inverse function, okay, what is that definition? Dx upon dy is equals to 1 upon dy upon dx, where this dy by dx is not equals to 0. Now substitute the value of dy by dx, and therefore this dx upon dy is equals to 1 upon, okay, 1 upon 25 plus 25x square, 25 plus 25x square plus 2x upon 1 plus x square upon 1 plus x square, and hence dx upon dy is equals to 1 plus x square upon 25 plus 25x square plus 2x. Okay. Therefore, the rate of change of demand X of commodity with respect to its price dx upon dy is equals to 1 plus x square upon 25 plus 25x square and plus 2x. Okay. Or it is written as dx upon dy is equals to 1 plus x square, and this divided by 25x square plus 2x plus 25, and this is the answer. Okay. Easy problems అయితే you can see this. First, find out the derivative by the definition of the derivative of inverse function. Okay. And lastly, the rate of change of demand X of commodity with respect to its price, that is nothing but the dx upon dy, and here's the answer. Now the next question. Find the marginal demand of commodity where the demand is X and price is Y. Again the same type of the question. Therefore Y is equals to X into e raised to minus X plus 7. Now differentiate this with respect to S. Differentiate with respect to X. Okay. And therefore dy by dx here we will apply the product rule. Okay, that is ddx of x into e raised to minus x, and derivative of constant, that is a 7, is a 0. Now here the apply the product rule. First x, derivative of e raised to minus x is a minus e raised to minus x. Next the derivative of x is 1 into e raised to minus x, and overall you will get here minus x into e raised to minus x plus e raised to minus x. Now from here you can take e raised to minus x as a common, then in bracket you will get 1 minus x. Okay, and hence dy by, this is the dy by df. Now by the definition of the derivative of inverse function, by derivative of inverse function. Okay, therefore dx upon dy is equals to 1 upon dy by dx, where this dy by dx is not equals to 0. Substitute the value, then you will get 1 upon e raised to minus x in bracket 1 minus x bracket complete, and this is the dx upon dy. Okay. Therefore, the marginal demand of commodity, where the demand is x and the price is y, dx upon dy, and that's equals to 1 upon e raised to minus x in bracket 1 minus x, or it can be also written as e raised to x upon in bracket 1 minus x or 1 minus x only. Hence, therefore, dy upon dx is equal, dx upon dy, therefore dx upon dy is equals to e raised to x upon 1 minus x. Okay, and this is the answer. Normal derivatives फक्त काढायचे and then by the derivative of the inverse function, dx upon dy is equals to 1 upon dy by dx. Okay. Now the next problem. Next problem is y is equals to x plus 2 upon x square plus 1. And again here we have x plus 2 upon x square plus 1. Now differentiate this. Differentiate with respect to x. And therefore dy by dx is equals to, here we will apply the quotient rule. First v means what? X square plus 1 into ddx of u means what? X plus 2 minus x plus 2 into ddx of x square plus 1 bracket is completed, and this whole divided by x square. Therefore it is a x square plus 1 bracket square. Okay. Now the next simplification. X square plus 1. Now the derivative of x is 1 and the derivative of 2 is 0. Therefore into 1 minus, can here x plus 2, derivative of x square is a 2x and 1 is a 0, and this whole divided by x square plus 1 bracket square. Now the simplification. X square plus 1, 2x into x, then you will get minus 2x square, 2x into these 2 minus 4x, this divided by x square plus 1, it's a bracket square. Next simplification. 1 x square minus 2x square, then you will get minus x square. Next is a minus 4x plus 1. Okay, and here to the denominator, x square plus 1, it's a bracket square, and therefore dy by dx is equals to, you can take minus sign as a common, then you will get x square plus 4x minus 1, and this divided by x square plus 1, it's a bracket square, by the derivative of inverse function. Okay, by derivative of inverse function by the derivative of inverse function. Therefore dx upon dy is equals to 1 upon dy upon dx, where dy upon dx is not equals to 0, and hence dy by dx, therefore dx upon dy is equals to, what's the value of this dy by dx? That is equals to 1 upon, okay, minus in bracket x square plus 4x minus 1 minus in bracket x square plus 4x minus 1, okay, upon x square plus 1 bracket square upon x square plus 1, and it's a bracket square, then it will become multiplied and reciprocal, and hence you will get x square plus 1 bracket square upon in bracket x square plus 4x minus 1, and this is the dx upon dy, hence this is the answer. Or you may write the answer also, dx upon dy, and that's equals to in bracket x square plus 1, it's a bracket square, upon, operate the negative sign for x square plus 4x minus 1 instead of taking negative sign as a common, okay, that is a 1 minus x square minus 4x. This is also answer. Now the next problem, again y is equals to 5x plus 9 upon 2x minus 10. Now differentiate this with respect to x. Therefore, dy upon dx is equals to, what is that? First, v into, which is the 2x minus 10 into ddx of 5x plus 9 minus, okay, u into, means what, 5x plus 9 into ddx of 2x minus 10 bracket complete, and this whole divided by 2x minus 10, and it's a bracket square, okay. Now the next, 2x minus 10, okay, derivative of 5x is 5 and derivative of 9 is 0 minus 5x plus 9, derivative of 2x is 2 and 10 is 0, and this whole divided by 2x minus 10, and it's a bracket square. Next simplification, 5 into 2x, that is a 10x, next minus 50, next is a 2 into 5x minus 10x minus 18, okay, and this divided by 2x minus 10, and it's a bracket square, plus 10x minus 10x get cancelled, and hence you will get here minus 68 upon in bracket 2x minus 10 bracket square, and this is the dy upon dx. By the derivative of inverse function now, by derivative of inverse function, okay, by the derivative of inverse function, the dx upon dy is equals to 1 upon dy upon dx, where dy upon dx is not equals to 0, and hence therefore dx upon dy is equals to 1 upon dy by dx. What is the dy by dx? Minus 68 upon minus 68 upon 2x minus 10 bracket square, 2x minus 10, it's a bracket square, and hence dx upon dy is equals to minus, this will become multiplied and reciprocal, and hence it is a 2x minus 10 bracket square upon 68. This is the answer. Okay. And in this way, we have completed the exercise 3.2. Okay. I will see in the next video. Till then, goodbye. पुन्हा तुम्ही इथे बघू शकता.